Alright, hey everyone. So today we're going to be going over a quick lesson in just assemblies and how they work in Fusion 360 because if you're coming from Inventor and any other CAD software, they're going to be a little different. So we're going to go through that for maybe half an hour-ish, and then we'll be working on our personal projects. First of all, does anyone not have access to the ASME drive in CAD or not know? If you don't know it, then you might not be in it. So, because you will be needing access to that. So I'll actually, let's get started. I'm gonna see who has it or not, and then we can take like 5 minutes to get you added to that. Okay. All right. So start up Fusion 360, and just go to your untitled project, and we are going to be working with parts from the ASME drive. So what you guys, hopefully you guys are seeing what I'm seeing here. What we're really going to do is we're going to go to show data panel up here, top left. We're going to click on that, and we're going to create, for you guys, we're going to go into the CAD training folder, and you're going to go to your members folder and just create a new file design in your folder. So if you have a folder already in one of these, if one of these is yours, then you can open it up and add your design. If not, just go to new folder and put your name in there, and then we'll go on from there. I'll actually create one of my own right now. So I'll give everyone a little time to do that. And raise your hand if you need help getting there. Jordan, can you open up the invite? Yes. So this is where you're going. So you remember you have Fusion, the Fusion camera.
And you're going to have to open your Purdue email and just do that afterwards.
Well, we create entirely the blue separate content. That's the public, there's some blue separate content. So the examples of the bigger content. So, it's not.
So we just started. You're not too late. If you can go open up Fusion 360. Are you in the ASME?
Yes.
Okay. So once you open that up, go to your members folder and create a folder for yourself if you don't have one already. And we're going to be making all our parts in there. I'll give it like 2 minutes. So you guys, just yeah. So I'll give it 1 more minute. Let's look at that. So are you in your phone? So you have the ASP drive right now. So you don't have that. Yeah. It's like a shared drive that ASP has with home. So that's the top. You got one over there. All right. All right. I take it everyone's good now. Cool. All right. So what we're gonna do here is we're just gonna make a new design like we normally do. So I'll run through it one more time in case everyone's forgotten. We're going to go to the top left. We're going to hit File, the File drop-down button, and we are going to hit New Design. Now it should create a new one. If you already have one before, then that's fine. Just we need a new blank canvas. And then we're going to Control S or just go here and save, and we're going to just call it bus assembly. So we name it that, we're going to save it as that. Alright, so now that we've saved it as bus assembly, we are going to go to our data panel here, hit show data panel. We're going to go back out to the CAD training folder, and we're going to go to bus assemblies original, and we have 3 parts that we want to use to create this assembly. So what assemblies are it's a file that you can place multiple components or parts into, separate part files, and arrange them in a way that you can create more complicated and more intricate designs. So here, right now I'm just going to show this off. We are going to just be making this bus. We're making this bus assembly, so we're going to be working on attaching these wheels as well as this window pane on the bus. So let's go back into these 3, and we're going to highlight all of these and make sure we're back on our original bus assembly file that we had from our members folder. Once we have that, we can go through each of them and we can say insert into current design. And what that'll let us do is that'll let us add it to our current file. And so here, when you move any part into an assembly file, you can have the options to, translate it, rotate it any which way we want. But for right now, since this is our first part, we don't really need to, modify it in any way. So we're just going to hit OK. And now if I go back to my members just to confirm, yeah, bus assembly. This is my part file that I have right now, and this is the part that we have contained. So we're going to do that same process for the bus frame, the bus wheel, and the bus window. Now for the bus wheel, you want to import it 4 separate times. So you're going to just go through that insert to current design process 4 separate times. So I did the same thing. I hit insert into current design, and then I'm just going to place it so that it's out of the way of the bus frame that's already there. Hit OK, and then I'm just going to repeat that process until I have 4 wheels in my assembly file. Oscar, do you mind helping him?
Is it possible to make like several?
You can create copies, but you can insert it once and then create 4 copies. But I don't think there's a way to say X amount insert X amount. So it's a little bit tedious, I realize, but this is the only way I know how to do it. So just to import it 4 times. Make sure all these wheels are out of the way. And so whenever you're working on a shared project, something like in one of your design teams, and you need to make an assembly with a part that someone else made, you can insert the current design into your design and have it not affect the original part, which is going to be very useful. You don't want to accidentally change the original part file that someone else was working on for your project. So this is, just make sure you do this so that, you know, both separate files, yours and theirs, are separate from each other and won't be affected. So, show of hands, everyone's good, everyone's got all the parts in there. So, no one needs help. Alright, and so now that we have all our parts that we want to assemble, we are just going to be learning the different types of connection processes. So if we go up into our toolbar, we have, you know, different create, modify, assemble, construct, some things that we've been using all semester. Today we're going to be just working with the assemble toolbar. And so if we can see here, we can see that we have 2, you know, base options, new component, which is what we were doing before when we were dragging it in, and then joint, which is the main thing that we're going to be using. If you hit the drop down on assemble, you can just see different types of assemblies that we can be working with. But today we're just going to be going over just joint, the base one. So we can go drop down, joint. The hotkey is J, or you can just hit this. And so once we click joint, we'll be presented with this prompt that allows us to select 2 different components to then connect. And so the way Fusion does these joints is a little bit different than SolidWorks or Inventor. It prompts you for a surface and then a point at which to connect both different components. And so if I just demonstrate it here, I'll work with one of my wheels. So as we can see here, I can select the surface, and then I need to select a point at which to align with my other connection point. So let me just show off with one of the wheels first, so we can just get a good look at this first, and then do the rest of them. So I'm going to select the surface, which I want aligned. I want this wheel aligned with this surface here, the surface, guide for the wheel. So I'm going to select the surface of the wheel, and then I'm going to select the center here. And so what that's going to do is that's going to allow me to, my apologies. One thing we need to do first, we need to ground our bus frame because as we can see here, we can move every single part here, and that'll create a little bit of messiness when we kind of start adding parts. So what we want to do is we want to go to bus frame, and we want to ground it. So we want to left click it, and we want to ground bus frame. We'll be prompted with this. It'll ask us if we want to revert or capture the position. If you've moved it around before doing this, just hit capture position, because we'll just keep it how it is right now. And now if I try clicking on my bus frame, it's not going to move. And so this will be a good placement point for all of our parts to go into. And so now we can start working on our joints. So I'm going to go back to our joint prompt. And before placing any positions, we're going to go and just look at the motion tab over here. So you have position and you have motion. And we have all these different types of joints that we can make. Rigid, revolute, slider, cylindrical, pin slot, planar, and ball. Feel free to go and kind of research some of these on your own time, but the two main ones that we're going to be going through today are rigid and revolute. And so for attaching these wheels onto the guides on the bus frame, we're just going to be using the revolute, which allows us to align axes rather than surfaces. And so once we have revolute as our motion selection, we can go back to position, and we can start selecting our axes. So what I'm going to do is I'm going to hover over the axis of rotation on our wheel, and it'll come up with a cylinder that allows us to place 3 different points on it. Like I said, joints and fusion work a little differently. They require 2 different types of connections, a point and just a plane or an axis. So what we're going to do here is we're going to hover over it so that we see the axis as well as our little tiny coordinate plane system, I guess, right here. It's red, green, and blue. We're going to click on that. And now that that's transparent, it means that that's one of our components that we're connecting. We're going to do something similar with this guide over here. And as we can see, we can place it anywhere on this axis rotation there. What you want to do is you want to kind of highlight the end of here so that, as we can see, you'll have the wheel be flush with the peg. Yeah. So you want to create a member file for yours. Yeah. And so you want to, okay. So this is the bus assembly that you're working, right? These are the same file. So go back up to our original. Go back to, and instead of like dragging it, just hit left there. Right. And you want to insert into your design. So that'll let you then edit this. So right now it's just overlapping the thing. Yeah, that would be it. So if that's what your question is, sorry, I didn't. And so as we can see here, our surface of the wheel is now flush with the surface of this guide because those, we selected the outer points for both of those. Once you have that, you can offset it however you like. And then this will lock it in place after you make that connection. So if I kind of rotate to the underside of this bus and just see, right now the wheel is kind of jutting into the bus frame. and we don't want that, so I want to kind of bring it out a little bit. So I'm going to bring it out so that's 0.2 off the offset. And this is a little tricky thing with Fusion, is that you got to make the offsets before, and it can be kind of finicky, not having the exact. Huh?
Click on that face. Oh, wrong side, but yeah.
Okay.
Now you know the offset.
Yeah. Okay,
Flip.
so yeah, the offset is now, so yeah, all right. That's a good point. So let me show that off then.
You can also join from the inside of the wheel.
Yeah. I'll demonstrate the flip though. So,
Yeah.
so if we just do the same thing, we can, oh, that is not where I wanted to go, sorry. Let's try this one more time. So I'm gonna unselect. So I'm going to do the same selection process with these two outside ones. Okay, and now we can place it here, and we can move it so that I can just select this inside edge. And that, A, will give me the distance between, you know, this point and that point. And then we can flip it so that it is flush with this side of the bus frame. So you can utilize this flip option to just orient your parts better in case they don't automatically go where you want them to, as well as just use this offset. Yeah, so with these options you can just kind of position it how you want to. For right now, we'll just make it 0.2 from the edge here. And now we have a wheel that will, sorry, I made a mistake here when I did the joints again. I didn't hit Revolute. So now this will Revolute. In case that happens, you actually do a rigid connection. Just go down to your timeline and double click it and edit it. And then you can just go back and hit Revolute. And then we can see that now it's working how we want it to. Okay. So now, as I can see, if I drag this wheel and kind of spin it around, we are demonstrating the Revolute joint, and it spins how we want it to. So I'm going to do this just process one more time for this other wheel, and then I'm going to have you guys try it on your own. So we're going to go to Assemble. We're going to go to Joint. We're going to go to Motion. We're going to make sure we choose Revolute. We're going to go back to Position, and now we're going to choose our two components, which are just our two parts that we want to connect. I'm going to select the outer points on the axis of the wheel, and I'm going to choose a new guide, one of the other guides that we haven't used yet. So I'm going to place it there. And now, what happens if I mess up my connection and I place it somewhere where I don't want to? Say, I selected this already, but instead of placing it on the outer edge, I place it in the middle. As we can see, we're a little bit farther out than we want it to. Now, what we can do is just we can move our offset so now it's different. We can move our offset so now we can just place it back where it originally was. It'll give you a different offset number, so it might be confusing. So what we can do is we can just click snap to this surface and then move it out how many ever inches we need to so that it's in line with our other wheel over here. And so this is a little annoying thing about Fusion, is that you are going to have to make sure that your points at which you connect these components are consistent. And if they're not, just make sure you know the math to get everything kind of shaped right to your liking. But after that, after making sure that everything's okay, you can hit OK. And now you have a second wheel. So now I'll give you guys, I guess, 5 minutes to just get the other wheels on there. Make sure you utilize your offsets, your flips, to just align it the way you want to.
a way to like join these together so they spin together like there is in convention?
Motion studies. Yeah, so
Yeah, like if I wanted to spin this.
so underneath the symbol you have motion link. So motion link basically allows you to do is you can add relationships between joints. So you can basically, you're going to click on both the rotational joints and you can basically put like a 1-to-1 gear ratio.
Okay.
And they'll rotate together. So if you rotate the front wheel, the back one will rotate. It's a little finicky because it works, I think, in radians. So, well, in this case, it'll be a 1-to-1 ratio. But if you're dealing with like gears, it gets really finicky at times.
Huh.
But that's how you can link any type of motion together that are done together with joints. Yeah, and when you're like, I usually use Fusion and better for printing and in that case, you know, the linking doesn't matter as much. But for simulations, it would definitely matter. So that's something I left out on this one that we can go explore later. Oh, so you got the wheels up. We're gonna go over the window. So it looks like we've got our wheels on there now, which is all good. I'm just going to hide these 2 wheels because I don't want to mess with them right now. But everyone else has all 4 wheels on there, so that's good. I'll just do this really quickly. So as I can see here, I want it to kind of flip it differently, depending on how you attach them. They're going to connect differently. So yeah, use your offsets and use your flips to just get them where you need to be, or where they need to be. My apologies. Okay, so now that all 4 wheels are on there, we're going to be working on just assembling the next part and using the rigid joint. By the way, if these joint symbols are bothering you, you can hide them up here. If you have a lot of connections, it might get a little annoying. So I'm going to hide these. All right, so now we're going to be going over the rigid joint. So we're going to go back to our joint prompt. We're going to go to motion, and if you're using Revolute originally before, we're going to switch it to rigid. And we're going to go to position, and now the components that we're going to connect are the bus frame and the window. So what I'm going to do is I'm going to select any points on this window, on this surface, and I'm going to select any point I see here. Now I'm going to demonstrate a little bit of, I guess I'm going to demonstrate a mistake here that can kind of cause a little issues later. I'm going to choose the middle point, so if you guys just want to watch really quick, you guys don't have to make the mistake with me. Now that we have this window selected and we have the center point on this surface, I'm going to just make it so that it's flush with that, because I want to connect it from that surface, and I'm just going to choose this point. Now I can offset it, I can flip it however I want to, and I can just offset it here. So in some cases, if I'm like super far away or I want to offset it, I can't really get it perfectly in the frame. And if you really want to go and like super, you know, close offsetting, you can. It just seems a little unintuitive to kind of align it that way. So what we can do is we can utilize the different connection points when we joint to kind of make sure that we are having a snug connection. And so the issue was I selected a point on here that was not existing in our bus frame. So I chose the middle part of this surface, but we don't have a middle surface on that window. And so there's no way to kind of align it in a way that we find it intuitive. And so what I'm going to do is I'm going to go back to my window, and now here I'm going to do it right. Is I'm going to still select this surface, but I'm going to select the edge. And the reason is because we can see that we have a mirror connection point on our bus frame right here. And so, just demonstrating that one more time. Surface of the window, and then left connection point right here, or left origin. I'm going to do the same thing, so I'm going to choose this surface of the bus frame, and I'm going to choose this left origin point. And so now, oh, I also made another mistake. I was still on Revolute. So I'm going to choose rigid. It'll give a little shaking animation. I don't know why it does that. We can hit position, and now we can utilize our flips and our offsets. And we can make a snug connection without having to mess with any offsets afterwards. So this is a much more intuitive way to make sure that you are getting the best connections. You can still offset it, but I'm not going to because we already have it where we want it to. So I guess the most important lesson here is that once you make your joints, make sure you mess with the offsets, you mess with the flips, and mess with the connection points to make sure that you get your parts where you want them to be. But after we have this, we can hit OK, and now we have our bus assembly. And so now what we can do, I'm not going to demonstrate it, but what we can do is we can export this assembly to an STL file, which is the files that 3D printers take, and instead of having to print separate parts individually on these printers, you can print assemblies, and that allows you to kind of get a lot more intricate designs that you can then print. I don't know if anyone's seen like the Dragon 3D prints. They're super bendy and intricate, and they have joints already printed. And the way they do that is they make an assembly of those joints, and then they print that directly to the 3D printer so that those connections are already there, and you don't have to make them yourself. And so this, the reason we're showing you this is just not only to make your, whatever designs you come up with a lot more complex and a lot more intricate. You're not just limited to one part file, but also if you ever want to go into like 3D printing stuff for your design teams or your personal projects, you can print out assemblies and have a lot more intricacy and complexity with what you create. And like I said, we left off a lot of motion, we left a lot of different types of joints. So feel free to kind of research on your own what each of these do and just kind of fiddle with them and see what works best for your project. But other than that, today was pretty short. So right now I have a bus, 4 rotating wheels, and then just a window pane that is stuck in place.
So if you wanted to print this, would you have to send the assembly and the part files?
You do not print assemblies. You never
No?
print assemblies.
Why
you
not?
always print the individual parts and then you put them together yourself afterwards.
Why not? But you can print
You
assemblies.
can print the assembly, you just file export.
Well, you wouldn't print this assembly, but like you said, like the Dragon.
Like
or-
if you
Yeah,
like-
so you could, if you're gonna do that, you do file export as STL for the whole thing, but it kind of gets a little glitchy when you put it in splicing programs. Because when you export it as an STL, you have to open it in 3D print splice program, and then that splice program has to convert it. So sometimes it can get a little bit finicky there if it
But
doesn't.
So how would you do
You'll
that?
keep the joints though, right?
Well, no. Once you export it as an STL, it's literally just a mesh of the entire thing. So you'd have to design it so that the parts mesh around each other so that when it prints, you can't pull them apart without breaking them.
Okay. My apologies then. I made a mistake.
It's weird.
So if you wanted to print a design that had multiple separate parts,
Yeah. Usually, I'd say the best practice is to print them separately and put them together. If you want them to permanently stick together, like the Dragon example, you would design it in such a way where it's you have the neck of the Dragon, right, or whatever, and then it kind of curves in a little bit so that the next one wraps out and then kind of goes in so that you can't pull them apart.
yeah, but how do you send it to the printer?
You just file export as STL
Yeah,
the whole
so-
thing, and it will send them all separately.
So do you need the assembly and the part files?
No, you just need the assembly, and
Because what's happening is when you file export as STL, for the whole thing, it meshes the entire assembly into one like mesh body and sends that. But the issue is when you do that, it takes a long time to export because you're trying to export a mesh of everything, including the airspace between them. And it takes like a little bit longer because you're not just, this is the part, it's taking that part is relative to another part, and you have to have the meshes of both those things, and then it just takes longer and longer the more you add.
Interesting.
So that's why I usually say it's better to just export the parts individually because they export like that. But you can do it if you just do file export for the whole assembly.
But so different projects require different
Projects require different things. So like obviously the Dragon thing, you probably want to just export the whole assembly. But
If you can avoid it.
if you can avoid it, you want to try and
Mhm.
avoid it.
So in other words, if you're going to print an assembly, design it to be an assembly. If you're going to print individual parts and then put them together, design it that way. It's
Yeah,
all that. This all
Oh,
comes
yeah.
from a design aspect of 3D printing.
Yeah, exactly.
Mm-hmm.
Yeah, and obviously you're not 3D printing everything that you CAD, so there's
Right.
going to be things where you want to design it a certain way because you know that the final design is going to need to be put together, and if you
Mhm.
can't reach into a certain spot, kind of thing. So it's definitely a case by case basis.
Yeah, I should have mentioned that. You can't just print. Yeah.
Yeah,
I mean, you
You
can,
can,
but
but-
there's stuff that is obviously easier to print separately, like
And
top, bottom up.
Even if you wanted to print this as one piece, that would be kind of hard to print.
Right.
size.
Yeah,
So-
well, and just because, I guess you could use support some.
You
Yeah,
use
yeah.
supports, but obviously the bottom might not be as good.
Mhm. And if you want, you can just go to File, Export over here, and then choose STLs, and that's you can do that for any part as well.
Yeah, and then there's also the 3D print utility. So if you're at an assembly, right, and you want to just print the parts from the assembly, if you go to cancel that real quick. If you go to utilities, the 3D print icon on the mid left, or left, that one.
Oh, gotcha.
3D print, if you click on that, you can select one of the parts, and you'll notice when you try to use the 3D print utility, it will only ever select a single part, because it doesn't want you to select the full assembly. Because
Okay.
it doesn't think, because it doesn't want you to do that because it's not a good idea.
Hmm.
But you'll notice here you get like refinement is medium. You can change that to high or low, depending on how detailed you want it to be. You can also send it to a print program. If you have a splicing program for a printer on your computer, you can send it the file path to that, and it will automatically send it to that program.
Oh.
Much recommend doing it that way. The settings are typically more specific towards the printer, so Fusion has their own settings, but if you can do it on the printer settings, it's going to be way better.
Exactly. But this is just nice
This is a
if you want to
default.
export as an STL. So usually I uncheck that last box and I export it regularly to like the program. So yeah.
Yeah.
So there's a few different ways to 3D print stuff if you're interested.
Mm-hmm. Yeah. All right. Well, yeah. I mean, that's really it for assemblies. Like I said, I hope this kind of allows you to design more intricate stuff to at least show off and visualize how it will simulate.
Can you show us how to color it?
Yeah. Well, there aren't. Are they colors or are the materials? Can you do either or?
Either.
They
Okay.
both color it.
So there's, if you go to inspect actually. I think
Actually, I'm
there
gonna
should be-
pause this because this is now unreal.